Thank you. What about Albany?
Yes, ma'am.
Thank you. Okay, Savannah, so are you online? Awesome, okay. All right, so today I'm just going to open it up for questions as a review session. So if there are particular things on your mind, things you're wondering about, things I can help clarify. If you're at a distance site, of course, you're going to have to just call it out. I can't call on you if you're on a distance site.
Awesome. Oh, that's a night shift if I've ever seen one. Oh my god, that is extreme. Hers is like extreme. Mine's on night shift and then I'm like...
Okay, so lecture 13 was on the clinical implementation. And so the majority of that was in-class exercises looking at one-on-one results and analyzing patients and then figuring out the disease. So no, 13 will not be part of exam content.
Is the test multiple choice, true, false, short answer, etc.?
Okay, good question. So most of it is multiple choice. There is one true false question, I believe, and there are maybe 4 or 5 fill in the blank. And fill in the blank is not usually, it's not short answer. It's not sort of write a paragraph or something like that. But I think it's around 4 or 5 fill in the blank.
How many questions on the exam?
So right now, there are 32.
What? That's not a lot. We need like...
There might be a couple of more,
Can you have like 32 more?
but I don't expect very many more.
Are they all equal distribution?
I haven't pushed it through yet because I always like to sort of think about it, and sometimes I realize that something is sort of misconstrued or it might be more difficult to understand the more I go back and look at it and reread it. So right now it's 32 questions. And I might add a few more. So the majority of it is multiple choice. And as you're probably familiar, some of my multiple choice are more than one answer. So most of the times it's one answer. But then there are other times where I might say select all that apply, or there's more than one, things like that. So it depends, but usually it's going to be one answer. There's at least one instance where when I write the question, I'm not writing the name of the drug, but I'm giving enough information that you would know what the drug is. And so instead of the drug name, I have sort of blank. And I'm not asking you to fill in the blank on that question, but I didn't want that to throw you off. I don't think it will. I think it'll be very obvious. But it's not a mistake on the exam, like it's done deliberately, because in asking the question, if I gave you the drug name, it would be too easy.
Well, the only drugs we need to know are like more.
Yes.
Would you mind briefly going over one more time which lectures are going to be on the test and which ones aren't?
Sure. Alright, so let me pull up the doc camera for this.
I like it when you just give like a brief overview. Especially when the first test is until October. Yeah. And we haven't had them. Yeah, like we've had some first tests to kind of I know. Just be reviewing.
Yeah, she didn't do that. Like 4 might be verified.
Okay.
Yeah.
So So on the exam, I'm including material from the Fundamentals of Human Genetics, Genetic Effect on Metabolism, Pharmacogenetic Tests. Not necessarily content from here, but you should know your resources. You should know PharmGKB and CPIC. I also have content from lectures 10, 11, 12, not 13, but 14. So 13 is the one, I got that good question first to say, is that on the exam? No. That was just an in-class exercise. You've already been graded on that. I felt like we covered what I was trying to get at, looking through patient information, making a recommendation based upon that information.
It looks like you want to know something from lecture 9 to, what does that say? Basic info on the FDA?
Just basic information. So for example, just that the FDA is out there and they have these websites. There's really not anything else other than that.
Dr. Murph, that paper's not showing up well in Augusta. Could you just name the number of the lectures that you just said would be on the test?
Okay, so 2, 6, 7, 10, 11, 12, and 14.
Thank you. I have a question, Savannah.
Sure.
Can you tell us that certain allele frequencies were higher in certain races, like star 10 and Asian population, etc.? Do we have to know specifics about that kind of stuff?
Yes. Yes.
Yeah.
Dr. Murph, could you also tell us what you wrote there next to lecture 12, please?
Oh, I was just writing down the alleles. That's just my notes. Sorry about that.
Did you get that picture before she crossed it out?
Yes.
That looks like a test answer.
Highly doubt it.
She stopped sharing. It was a test answer.
Star 1, star 2, star 3. She like said that we were doing it.
What does it say after star one?
Go to send it and then it's thing.
I was just about to.
Yeah, any picture you get, make sure it gets.
Someone said that that's an answer.
I have to pay for it.
Dr. Murph, this is Genomics in Albany.
Other questions?
Is that Felix over there in the corner?
Yeah, you can't see him.
For the tables that we went over in class a lot of them, do you know specific ones that we need to memorize and then specific ones we don't as much, or more so I guess what we don't need to memorize?
What?
Okay, so let me give you an example. Or if you have like a specific lecture, without going through
Star 1, star 2.
every single slide, which might possibly give away questions in a sense.
Just give them away.
We don't really feel like that's okay if we give them away.
He's asking you. Oh, what you want me to do? If you have like a specific example.
I'm looking, hold on 1 second.
I wonder, like, if she's gonna
Just,
do like an
just
excuse
ask
where
her
I have to
some of the
memorize
lectures
all
you said
of
were
them.
going to be on the test.
Okay, so
Any of those.
without going through specifics, because I have to sample your knowledge, but I do want you guys to go out into the fields of healthcare and be well-educated, well-prepared pharmacists. And so in learning this material, I don't necessarily expect if you're on your 3rd or 4th year working in the pharmacy that you'll say, oh yeah, that CYP2D6 allele, I remember that. It's great if you do. What I'm trying to get at is that it rings a bell where you say, okay, I remember something about that. I probably need to go back and check to make sure that I understand the function of that allele. I can interpret this patient's genotype and phenotype, and that we can get them the best drug for them. So, for example, information, when I'm giving variant examples, the RS numbers, the G to A, C to T, this is just to give you a flavor of how much information is out there and how technical and how complicated it can get. But I certainly don't expect anything like this to be regurgitated on an exam. If you would need this information in the clinic, you could look it up. There are certain alleles that CPIC and PharmGKB pull out into their tables, and those I consider recommendations for what pharmacists should know when they're on the job. So I'm giving alleles star 1, 2, 3, 4, 6, 9, 10, 12, 14, 17, 29, 41, but of course you don't have to memorize this slide and say, I need to know everything about those alleles. Again, I'm just sort of giving you a flavor of all the information that's out there. So I don't narrow it down too much so that you're not prepared for what you could potentially see. But then there's information like, of course, this table. I don't expect you to memorize the table, but I do expect you to know the takeaways, and that if there are certain allele frequencies in the world of specific populations where it comes up that are pointed out, then yeah, you should know those specific populations, but I wouldn't think that you could regurgitate this from left to right. Like which one has no functional alleles, what percentage, like no. Just major trends that were pointed out. Then there are CYP 2D6 phenotypes and genotypes. So for example, this is a PharmGKB guideline. So the alleles that are contained in this guideline, you should know for testing purposes. And then after that, if you forget it, okay, and then hopefully an ancient brain cell at some point, if you need it, will recall it and say, I need to look up that star 41 allele because I know there's something suspicious about that, and I need to understand that, and that's fine. So what do they have here? You have star 1, star 2, star 4, 5, 10, and 41. And we're only talking about CYP2D6, 9, 19, from the lectures. I thought there were about 4. So when it gives a table like this, it'll just give a few examples of the haplotypes and the diplotypes that they're considering important. So information here would be important to be able to interpret what this would mean, but I don't expect you to regurgitate a figure like this, or like this, or like this, or this. So I'm trying to just hone in on what they consider the most important guidelines. Does that make sense?
That was very
But, okay, but if you have like specific lectures, and so this comes up in a couple of lectures where, you know, I might be giving you on like an introductory page all of the possibilities, but of course that's me just saying, here's what's known, but we're just going to narrow in on these specific alleles because those are the most important ones in the guideline. But there's a lot more information out there.
Dr. Mark, I have a question.
Sure.
I think it's with 2D6 where if they have like a strong inhibitor or mild or moderate inhibitor, you have to multiply by a certain, like 0.5. Do you want us to memorize what is considered like the strong inhibitor, like yeah, that side?
No, you will not need to memorize this list. My rationale for that is that I figure you can look up that type of information. But it's quite a list to memorize. I guess I kind of thought you guys might know that anyways, but if you don't, then I wouldn't expect you to memorize it. I think you can look it up if you need it. Well, and there's certain drugs on here too that are like niche, so scratch what I just said. But don't memorize it. If I have a question about the strong, moderate, or weak inhibitors, I would provide that on the exam. So I wouldn't expect you to memorize a list like this and be able to regurgitate it. Say, I know exactly what that's going to do and how that is going to multiply into the equation and change the scenario.
Would you suggest that we practice calculating those activity scores?
Sure. I don't think you'll see that often, but I think if you're at the point where you're studying, you feel pretty good about it, if you did practice that, when you see it on the exam, you're going to be that much more confident and just, okay, got this. So, yes.
Do we need to know therapeutic recommendations based off of the phenotypes?
Okay, so where? Okay, so overall, probably yes, but is there? I'm thinking about this. So this was informative. So yes on this one, in terms of if they're a poor metabolizer, we've got a 50% reduction. If they're moderate, if they're extensive, they're intermediate, starting dose. And if they're ultra rapid, select something else. Similar down here, but there's no recommendation due to lack of evidence. So yes on this one.
I can't see that.
It's in the duty sector.
We just supposed to know the fluvoxamine and the Paxil for that because there are other SSRIs on the page before that, but the recommendations only have 2 of the drugs. Are we just saying those are the same for the rest of the drugs, or just knowing those 2?
Just knowing those 2. Here I was cutting and pasting information from their supplementary figure, but I don't expect you to know this slide. So we're saying this, but not this.
Curious, there were a few like dosing algorithms depending on like what allele or whatever they had for 2C9 and B4. Do we need to know the different doses and how to adjust it specifically, or just like kind of if they have a non-functioning allele, we'll need to give them a lower dose and just kind of know the basis of that?
All right, so I think you're asking about the calculators. Maybe I'm wrong, so tell me. But the calculators, I mean, no, I'm not going to be able to give you access to a calculator, so I'm not going to expect you to calculate a very specific dose from the online algorithms. So that's one of the reasons why we have a little bit more in-class activities with this type of course, because I need you to get to the point where you're applying this knowledge, and some of this can't be done on what we would consider a standardized test. So in this case with the algorithms, no. I think that was your question.
Yeah, that was. And I was asking more for like, not the online calculators, but like slide 15, where it gives you specific dose adjustments when they have different types of alleles, not taking into account their age and everything, just the two genes.
A rough estimate. So what does that mean? That means if we go back to something like this slide, where you're adding the different alleles together in terms of if you have a wild type with a wild type, or heterozygous with a heterozygous, or homozygous, how does that change the dosing? So just sort of a generalized view of this picture. So this is a little bit easier conceptually to wrap our minds around versus just numbers. You know, your mind typically thinks in pictures, not in words or numbers. So I include this graph because it gives the same, or I include this table rather, because it gives the same information as the graph, but the graph does a better job of sort of visualizing the estimate of, you know, if one is wild type and the other one is heterozygous, how does that change the dosage? So from a very general standpoint, understanding this concept is important, but memorizing the precise, let's say, milligrams per day dosage isn't something that I would ask so specific, but the generalized concept of how do these genotypes affect the phenotypes and the dosing, that's a yes. Okay, does that make sense? In terms of what would be the difference between understanding this general concept versus what I'm not asking you to do, which is give me the milligrams per day dosage, necessarily. Because I'm just not sure how you can memorize a table like this, and if that's even appropriate, with something that you can look up, something that can be calculated, and that's how it would be dosed, versus just understanding the concept of, you know, if I have two wild type alleles for both CYP2C9 and BKORC1, well then we're going to be at 100% dosing. If one of those changes, then, you know, we're going to drop down and we're going to be at 70% dosing. If both of them start changing to heterozygotes, we're going to drop down to 50% dosing. If both of them change to homozygotes, now we're at like 20 to 25%. So you essentially here have 4 different tiers. Wild type is 100%. We drop down once, we're at about 70%. Both of them start fluctuating to heterozygotes, we're at 50%. If both of these have abnormalities in homozygous, we're at 20%. So if you understand that concept, that's what's important. if that makes sense. So think about it more in terms of the visual combination rather than trying to memorize numbers and lists, which I don't think over the long term will stay with you. I mean, you might be able to do it for tomorrow, but my goal is to have you guys know this sort of long term so you can recall it if you need it. Or you can at least recall that there's something there that you need to go look up or check out. So does that answer your question?
It does, thank you.
Okay. Other questions? If not, we can wrap this up.
I have one more.
Okay, go ahead.
On the pharmacogenetic test, the lecture 7 was an question. I just had a question about, I know you said that like ethnicities and everything is important, but for the ones at the end for the hypercholesterolemia where it says the frequencies of different ethnicities with familial hypercholesterolemia, there's a lot on that, those 2 slides. Do you want us to know all of them, or do you have some specific ones you'd like us to know?
I think you mean slide 1.
Okay, this is a good question because I certainly don't want you guys to pore over some of these tables thinking she's going to ask me the percent of frequency in Japanese population for, if I pointed out like major trends, especially if they're written on the slide, major trends in what we're seeing a lot in the clinic and how different ethnic frequencies really distinguish themselves, that's the kind of information that we expect for you to know and recall. It gets complicated because we're so diverse in this country that people could have different diverse things in their background and maybe they wouldn't even know about it. So there's that. But a graph like this, what I pointed out was that so that this population is high as far as the Ashkenazi Jewish population, and that the Danish are the lowest. So for that, that's it. Please don't go through and start looking and memorizing every single little detail. I'm just trying to sort of establish major trends, and also so that you guys get a flavor of, it really depends on the genetic background. There's not one particular ethnicity that shows up in all different types of frequencies for things. I mean, it's really, really diverse and really interesting. But just like major trends. So that's a good question. It's a valid question. questions? All right, going once. Going twice. I'm available. I'll hang around a little bit longer if there are other questions. But if not, we'll conclude and we'll wrap up. Thanks for your attention, and I'll see you on Thursday. Bring your laptop computers, because we will be using ExamSoft, so that's how we administer, you guys know that by now, your exams in the third year. And I will have a code, we'll type in the code. I'll give you a scratch piece of paper. You can have a writing utensil, can't have anything else. I'll give you scratch paper, have a writing utensil, and your laptop, and that's it. All right, see you on Thursday.